Alrighty, today we're going to do simplify radical and rational expressions. It's the second half of our 11.2 notes. We split it up because when we did 11.1a, we were just dealing with whole numbers. And now with 11.2b, we're going to deal with those fractions and converting things to radical or exponential notation. So we're totally fine with this. The rules are the same, okay? So when you are multiplying, and you can even rewrite that PEMDAS staircase up here so that you can remember. So we're just going to jump right into it. I was going to go through the properties again, but if you want to go through them, then go look at that 11.1a video. So you have things with the same base. Do not multiply the bases, okay? You keep the base, that's what the property says, and then you add the exponents. So when you're adding fractions that you see match the bottoms perfectly. So this is really 5, and then you keep the denominator, and that's 4. So then that's 5 squared, which is 25. Okay? So there's the answer for that one. Next one, they have the same base, so I add the exponents. 1/8 plus 1/2. Now, these do not have common denominators, so they need to get common denominators. So I'm going to multiply this by 4. So big base of 7, and then my numerator is going to be 8, but I have this 1. Sometimes kids forget the 1 from the first fraction, plus 1 times 4, which is 4, and that will give me 7 to the 5/8. So sometimes students ask, like, hey, Wilkin, do I need to rewrite this in radical notation? So the answer is, unless it tells you to, then you don't need to, okay? So, or if it's going to help you simplify or something like that, but these ones don't, maybe the next one will. Let's take a look. So 16 to the 1/4 plus 1/2. We need common denominators, so this needs a times 2. So then I get 16, and the common denominator is 4, and the first numerator, which is this guy right here, is 1, and then I have plus 1 times 2, which is 2. So this equals 16 to the 3/4. Now, back up here, this was a nice whole number of 25. This one, can I get 8 of a kind out of 7? No, but can I get 4 of a kind out of 16? So in this particular one, it makes sense for us to convert this because we can simplify it. So what is 4 of a kind out of 16? So in your head, your gut is telling you 4 times 4 is 16, but this isn't looking for pairs. It's not a square root. It's a fourth root. So we need to take it a step further. So that's going to be 2 cubed, which is 8. Okay? Moving on, same type of problem, 32 to the 2/5 plus 1/5. Oh, so cool, they have common denominators. So this is 32 common denominator, 2 plus 1. You could probably do this one in your head a little bit easier than the last one, but I'm really going to map it out for you. So then you're going to ask yourself, can I get 5 of a kind out of 32? So it's the 5th root of 32 raised to the 3rd power. So can I get 5 of a kind? Yes, it's 2, but then we have to the 3rd power, so that equals 8. Okay? That's that one. Next directions, simplify using the power of a power property. So what you guys have to learn in this lesson, and this is why I like the PEMDAS staircase, is we were just working on multiplication, so you could see the multiplication dots in that problem. So when you wanted to know, as long as they had the same base, what you did with the exponents, you just stepped down to the adding part. Well, this one is one base. Do you see how you only have one base and a bunch of powers? So this is product of a power, and it says when you have a product of a power, you're just going to, or power of a power, I should say, when it's power of a power, you multiply the exponents. So it's a power, we're going to step down and multiply. Or you can think of it as exponents. The P actually stands for parentheses. But we got a bunch of parentheses here too, so it kind of all works well together. So this means 3 to the 3 halves. And now instead of adding, we're multiplying by 2. And we love multiplying fractions because we don't need common denominators. We just multiply top times top over bottom times bottom. Or you can also see, because we're multiplying, these are common factors, so they cancel. So I just end up with 3 cubed. 3 times 3 is 9, times another 3 is 27. Okay, next one. Oh my goodness, I love it. So we're going to multiply, so my base is 8. There's a whole bunch of parentheses here. So I take that and I multiply. Now the 11s cancel because they have common factors. Again, no pluses or minuses. That's why I can cancel these. Up here, if I ever had like something, is there anything? No, I didn't. But let's say this was a 2. Right here, I couldn't cancel that with that 8 because of that addition sign right there, okay? It has to be multiplication. So then you're like, oh, that's negative 5 over 15. Oh, I can reduce those too. Those are both divisible by 5, so that's negative 1 over 3. Okay, now we're bringing in all of those properties of exponents. It's a negative exponent. We answer with positives ones. So this one gets move downstairs so that it's positive because it's negative upstairs, and then keep that 1 there. We're going to do power over root. So the root is 3 and the power is 1. So can I get 3 of a kind out of 8? Yes, it's 2. So that whole problem simplifies to 1/2. Okay, let's go do C. So we got 1 over 25, and then it's going to be raised to the negative 4 over 7 times 7 over 8. Oh, I love these common factors. They cancel. So I kind of feel like maybe something that we can remember is like these cancel, so we're kind of like going through the dots, like connect the dots. That's the only time you can cancel. So up here there's no dot because it's not multiplication, so you can only cancel when you can connect the dots. Okay. So 1 over 25 raised to the negative 4 over 8. So most of the time these things will be in parentheses just to be really clear that this exponent goes to both the numerator and the denominator, not just the denominator or not just the numerator. So put them in parentheses when you have fractional bases. So you guys know that that's going to reduce to negative 1/2. Okay, so then I'm going to come up here to finish my math. It's negative upstairs, so it's going to move to the downstairs apartment. And we have a placeholder, 1 empty room up top. And then now I can convert it to radical notation. So I'm going to write this as the square root because it has a root of 1 over 25. And so we still have that 1 in the numerator. This is getting really messy, but we're okay. So square root of 1 over square root of 25. I ran out of room, but I'm going to make it work. So that's 1 over 5. And so I have to copy dot. So this is new. Whenever you have 2 fraction bars, you got to copy dot flip because you're only allowed to have 1 in math. So that's 5. So that equals 5. Way down there, we'll put a box around it. So that's that problem right there. All right, moving on. Let's go to simplify using the product of powers and quotient of powers. So right here we have 3 items with the same base, but we can't just go canceling because order of operations says take care of your exponents first. So you can't cancel your common factors till you're done with your exponents. So we keep the same base, and if we want to make it step by step, what we can do is take the numerator, which is 3/8 plus 1/4, and then put it over the denominator. So let's do that. You could also do it all in one step if you want. So if you're savvy enough to do that, go for it. So that's times 2 times 2. So that's going to be x to the 5 over 8 all over x to the 1 over 8. And then I'm going to come up here, and when dividing, right up here, using our PEMDAS staircase, when you're dividing with the same base, you subtract the exponent, so you write the x once, and you get 5/8 minus 1/8, which is 4/8, which is x to the 1/2, or the square root of x. So either of these answers in this problem works. But just even this top one is fine because you can't simplify it anymore by taking the square root. All right, let's do the next one. So oh, yay, they already have common in bases in the numerator. So I have 3 to the 5 plus 1 over 2. Sorry, not common bases, common denominators. They do have common bases too. All over 3 to the negative 2, which equals 3 to the 6 over 2 over 3 to the negative 2, which equals 3 to the third. I'm really spelling this out. Some of you guys can do this all in your head. Or not all of it. No way, not all of it. But a lot of you can. All right, and then this guy's not happy, so it's got to come up here. So we are multiplying with like bases. We're not going to multiply the bases. We're just going to add the exponents. So we get 3 to the 5th, or 243. All right, let's do part C. So we have, oh, I'm going to do the denominator first. Is everyone okay with it? Because I need to combine. Here, let me show you this other way that you could do it too. Because they're all the same bases, I could do 5 to the 5/6, which is the numerator. And then it says if you, the bottom one right here gets subtracted. Well, we have 2 bottom ones, so I could actually do this if you wanted to. It's up to you, but you could. Okay, so I subtracted both of them. Why did I have to subtract both of them? Because they are both in the denominator. I could also combine it and then subtract, so there's not just one way to do these. So I need to get the common denominator, so I get 5 to the 5/6 minus 1/6 minus 3/6. So that's 3 fractions, but all with the same common denominator. So 5 minus 1 is 4, minus 3 is 1, so 5 to the 1/6. All right? Okay, moving on. Now we're going to do the same thing with radicals. Sometimes students forget this, but when you have radicals, you're allowed, if you are multiplying 2 things, it's insides to insides with radicals, and when you're dividing, it's numerators and denominators. You can combine it into a single one, or you can split it up in 2. This does not work when you're adding or subtracting, okay? So you cannot just add 2 radicals together. They have to be like terms, and we'll go into that later, but for right now, we are going to figure out how to simplify these guys right here. So 75 is going to be, if you guys can all agree, 75 is 25 times 3. Now, this is a square root, so I picked a perfect square. So I'm going to leave it like that, and then I have x times x, and then I have y times y times y times y times y, and I have z. I need pairs, so I'm actually going to not leave this as 25. I was going to do something a little different, but I'm going to change it to 5 times 5. Okay, so you guys are all comfortable with that. So I need pairs. So one pair, under the square root, it's square, you double it. Out of the square root, it's single. So when it's under the house, there's 2 of them. When they go outside, it's just 1. So that takes care of that. All right, and then under here, the 3 doesn't have a partner, so it has to stay in the house. Okay, this x has a partner, so it goes out. Took care of that, took care of that. Oh, look at the y's. There's one set of partners, and then there's another set of partners, and then there's a guy left over, so sad, and another one left over. And then we're just going to clean this up a little bit. So this is going to be 5xy squared to the square root of 3yz. Okay? Let's go ahead and move on to B. This 3 tells us I actually need 3 of a kind. So because I need 3 of a kind, I'm going to write this out as 2 times 2 times 2 times 2. Instead of writing it as 4 times 4, I'm breaking it down all the way. So remember when you guys did these back in the day, they were called factor trees. That's what you want to do with these problems. Okay, and then 6 x's and 5 y's. So here's one group of 3. So cube root, make sure you put the 3 there because that's different than a square root, and I got 1, 2. Why do I only put 1, 2? Because the cube root of 2 cubed is 2. So I have 3 of a kind, so I put it out there, but there's a 2 left in there. Then I have an x, because I have 3 of a kind. Ooh, I have another x, because I have another 3 of a kind. I have a y. Oh, I didn't leave myself enough room. It's alright, we're gonna make it work. That's what whiteout is for. And then I have 2 y's left over. So again, we're just going to clean this up, and I'm going to put this here so that people aren't confused. That's 2x squared y cube root of 2y squared. Okay? Alright, now we're going to do our really long one. So we have the 4th root, whoa, of 625. So 625 is 5 times 125, which is 5 times 25, which is 5 times 5. Yeah? So we have 5 times 5 times 5 times 5. And then we have a times a times a times a times a. 1, 2, 3, 4, 5, 6, 7, 8. And then, if you guys want, instead of doing it like this, where we have to write out 3, well, we're just going to do it. 1, 2, 3. I don't know why I was saying 3. 12 C's. 4, 5, 6, 7, 8, 9, 10, 11, 12. So here's 1 4 of a kind. Sweet. That's outside. That's 5. Okay. Here's another 4 of a kind. Okay. That's A. I see this B. I'm going to leave it in a square. I'm going to come back and deal with it in a second. I have another set of 4 B's. So that's B, and another set of 4 B's, so that's B, and then a set of 4 C's, there's a C, another set of 4 C's, there's a C, and then another set of 4 C's, there's a C, and the only thing that got left in the house was that poor little A, home alone. And then we're just going to clean this up. Now, before I clean it up, I just want to point something out. What was the power here? 12. What's 12 divided by 4? Oh, my goodness, that's c cubed, which is exactly what I have. Okay, how many a's are here? Oh, there's 5 a's. How many times does 4 go into 5? Just 1 time, so there's only 1 a, but 4 doesn't go into 5 an even number of times. There's 1 left over, so that leftover 1 is in the house. Okay, b to the 8th power, what's 8 divided by 4? Oh, 2. Look, b squared. Okay, and there's none left over. So the only thing we have left to do is to put the a and the little 4th root, you can't forget that, back into the house. Okay? Flip it over. We are almost done. We are working on our last example. We are going to get our assignment done in class and have time to study for our test. Maybe we can make some flashcards or do something productive with our time. Okay. So now we're going to be applying those rules that we just talked about even more. So this says if you have a radical divided by a radical, the first thing that we need to know is that we can write it with only one radical. Okay, and this is a square root because there's no number written. Why would we want to write it with only one radical? Because then we can simplify the powers. So a to the 9th and a to the 5th, we learned that you can write that as a to the 4th. Because 5 of those would cancel, or you're dividing a to the 9th, the denominator gets subtracted, so that's a to the 4th. Okay? And this is b to the 1st power, so this is going to be b to the 4th. And you're not done. Okay, this is a square root out here. So we have a times a times a times a, b times b times b times b. 1 of a kind, or 2 of a kind there, 2 of a kind there, 2 of a kind there, 2 of a kind there. Oh my goodness, there's nothing left in the house. We just have a squared b squared as our final answer. Good. Okay? Alright, moving on. Now we have the cube root one. So we're going to do a gigantic cube root. You have to put that 3 there. It doesn't mean the same thing. Okay, x to the 7th, y to the 12th, over x to the 4th, y to the 6th. So I make it in one big cube root, and then I'm going to simplify the exponents, so I get x to the third, y to the sixth. Because 7 minus 4 is 3 and 12 minus 6 is 6, I have no negative exponents. Alright, so now I need 3 of a kind. How many times does 3 go into 3? 1 time, so I have 1x on the outside. How many times does 3 go into 6? It goes in evenly, so I have 2 y's on the outside. If you don't like that method, just write it out, guys. You gotta do whatever works for you, not what shortcut you want to do. I don't know why I circled only 2, because it's 3 of a kind. 3 of a kind, 3 of a kind, 3 of a kind. Alrighty, last problem. Whoa, we got multiplying and dividing in here. So the rule says that if you have multiplying and dividing, you can combine it under one radical. So we have the numerator would be 8 times 16, and the denominator is 4. So then we can simplify however we want. If we want to do 8 times 16, or I actually think what I want to do is I notice that this is multiplying, so these have a common factor. So that just got rid of my denominator. So I have 2 times 16, which is 32, and the fifth root of 32 is 2, because I can get 5 of a kind. 5 2's, so if I'm trying to do, I haven't shown you guys this yet, but this is what you're doing with it. When you do the 2 to the 5th power, and then the 5th root of that, this power is being undone by that root. Just like when we do x squared and we take a square root, right? That square root undoes the square. That's what lets us get like x equals. So that's what's happening when we say, oh, you got to break it into 5, and students will say, well, why do we only put 1, 2 on the outside? It's because you're simplifying that math right there. Alrighty, that's it for today.